Here are two examples of tree diagram. Example 1. If you toss a coin 3 times, what is the probability of getting 3 heads? When you toss a coin, it can be a head as denoted in red, and it can also be a tail as denoted as black. The chance of a head and a tail is equal, half-half, as 1/2. Now, I'll demonstrate how to draw a tree diagram. For the first time tossing a coin, we draw a tree with 2 branches, red as a head and black as a tail. We put the corresponding probability beside the branches. So we put 1/2 for a head and 1/2 for a tail. Now, let's toss the coin the second time. We will draw the branches again, red as head and black as tail. The probability of a head or a tail is half, 1/2. We put the probability beside the branches. Next, we draw the tree branches for the third time tossing the coin, one by one, and put the corresponding probability beside each branches. They are independent. That is, tossing a coin the first time does not influence the second time to be a head or a tail. For the first branch, it is red, red, and red as HHH, and the corresponding probability is 0.5 times 0.5 times 0.5 equals 0.125. Similarly, for the second branch, it is red, red, black. That is HHT, and the corresponding probability is 0.5 times 0.5 times 0.5 and equals 0.125. You can write each branch with the corresponding probability. Also, all the probability together is totally 1. So the probability for each branch, you just times all the lines which will lead to the branch. From the tree diagram, we now can figure out the probability that we get 3 heads if you toss a coin 3 times. Only the first branch has 3 heads, so the probability is 0.125. Furthermore, we can figure out other probability using this tree diagram, like 1 head. There are 3 branches having 1 head, HTT, THT, TTH. You can add all the corresponding probability together. 0.125 plus 0.125 plus 0.125 and equals 0.375. You can try some other cases yourself. Here is another example of tree diagram. Find the probability of drawing 3 aces in 3 draws of the poker card without replacement. Let's draw the tree diagram step by step. As we know, there are 52 poker cards totally, and 4s. For the first draw, we draw red as an S and black as a non-S. For the red branch, the corresponding probability is 4s card divided by the total number 52. For the black branch of the corresponding probability is 48, which we have 48 non-S card divided by the total number 52. Then let's see the second draw. Because it is without replacement, the total card left is 51. For this branch, we already have one S, so we have 3S left and 48 non-S left. So the probability for the red branch is 3 over 51, and the black branch is 48 divided by 51. For the next branches, we already have a non-S card, so we still have 4S left and 47 non-S cards. So the corresponding probability for the red branch is 4 over 51, and the black branch is 47 over 51. Now, let's see the third draw. We have total 50 cards left. You consider each branch how many S left and how many non-S left. And then you can find each branch's the corresponding probability. Then, for each branch, you can find the probability. For example, for the first branch, it is red, 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 S, S, S. The corresponding probability is 4 over 52 times 3 over 51 times 2 over 50. That is, you just time the corresponding lines to that branch. For the second branch, it is red, red, black, S, S, X, which X here is a non-S card. The probability is 4 over 52 times 3 over 51 times 48 over 50, and so on. From this tree diagram, you can figure out all the probability of each case, like only one S, or at least 2S, or only 2 S's, and so on. That's all for this video.